In this today's video, we are going to see some questions you might have missed in your JEE Main January attempt. Just because that is tricky, just because that is lengthy or advanced related questions. So in today's video, we are going to solve those missed questions. Okay, let's start with this one. 80 ml of hydrocarbon are mixing with 264 ml of oxygen in a closed U-tube. Undergoes complete combustion. The residual gases after cooling to 273 Kelvin occupy 224 ml. When the system is treated with KOH, the volume decreases to 64 ml. The formula of the hydrocarbon is. Okay, I have said that is a hydrocarbon, right? So CXHY, what is the general formula? X Y by 4 O2 gives XCO2 plus Y by 2 H2O. Right? So this is a general formula of combustion. What I have mentioned is 80 ml of the hydrocarbon. So hydrocarbon, that is 80 ml mixed with 264 ml of oxygen. What is the total volume? The residual gases after cooling to 273, that is 224 ml. So the gases, that is 224 ml. It can be, it's not only CO2, it can be oxygen mixed. Okay, so now what we are going to do is, first we have to find how much oxygen is unreacted. Okay, so this is 80 ml. So 264 minus 80 x plus y by 4 plus 264 is the total oxygen, and this much of oxygen is reacted plus 80x, which will be equal to 224. After treatment with KOH, when the system is treated with KOH, the volume decreases to 64. After reacting with 64 ml of KOH. Right, so 264 minus 80 x plus y by 4, that is equal to 64 ml. Because KOH will react with unreacted oxygen. Right? Unreacted oxygen. Now, what is, I'm simplifying this to get 64. 264, so overall I'll get 200, correct? So x plus y by 4, that is 2.5 then, correct? So from the first equation what we have produced, from there we can substitute the values of x plus y by 4. So 264 minus 80, 2.5 plus 80x equal to 224, right? So which is 264 minus 200 plus 80x, that is 224. Then 64 plus 80x equal to 224. Then x will become 2. Right? If x is 2, x plus y by 4, that is 2.5, right? So y will become 2 again. So the answer to this question becomes C2H2. Okay? So the calculations are simple. As I'm talking, it takes some time, but it is simple. Moving on to the next question. The elements P plus P and Q forms two types of non-volatile, non-ionizable compound PQ and PQ2. When 1 gram of PQ is dissolved in 50 gram of solvent A, delta TB was 1.176 Kelvin, while when 1 gram of PQ2 is dissolved in 50 gram of the solvent A, delta TB is 0.689 Kelvin. The molar masses of elements P and Q we have to find. This is an unusual question. It's non-conventional question from solution chapter, right? That makes you shocked to solve this question, but it is a simple question. Let's solve it. Anyway, that one formula for delta TB, right? Let's start with that. Kb into m. So Kb into, what is m? Molality. So the weight of solute into 1000 divided by mass of solute, molecular mass of solute, and the weight of solvent, right? Let's substitute for PQ. So for PQ, they said delta TB is 1.176, which is equal to Kb of A, that is 5 into, I have weight of the 1 gram of PQ, okay, into 1000 divided by solute, that I don't know, into 50 gram of the solvent. So what will you get as a mass now? Mass of solute, molecular mass of solute, that is 85. So similarly, you can do for PQ2, which is again M2, that will give you the same values again, right? 5000, 5 into 1 into 1000 divided by M2 by 50. So M2 goes on another side. Only the difference is, here I have delta TB value is 0.689. 0.689, which will give you 145.83. So what they are asking is molar mass of the elements P and Q separately. They are not asking what is the molar mass of PQ and PQ2. Right. So for that, what you can do is mass of P plus mass of Q, that is my 85, correct? And similarly, mass of P plus 2 the mass of Q, that is my, molar masses, 145, right? So these are the two equations I have. So just do the subtraction. This will get cancelled out. This will be MQ, which is equal to 145 minus 85, that is around 60. So Q, that is 60, mass of Q, that is 60. So what would be mass of M? That you can substitute it from the equation 1. So that will be equal to 25. Okay. So at the time of examination, you should think how we can solve it. That is the whole nature of the question. Okay. Then the next one. How many of you answered it right? Let me know in the comments. Thermodynamic process and then magnitude in kilojoules they have given. This is an advanced type of question. I know that this is slightly bigger. Let's see. The first one, work done in reversible isothermal expansion of 2 mole of ideal gas from 2 decimeter cube to 20 decimeter cube at 300 Kelvin. Let's solve one by one. This is isothermal reversible process. Reversible 2 decimeter cube to 20. So expansion. So for that, work done, that is equal to minus nRT ln V2 by V1. Correct? So just substitute the values. Formulas are simple. Formulas you already know, but it will take more time. That is the problem. Into temperature, that is given as 300 Kelvin. Ln 20 by 2, right? So W, which will be, this will be ln 10. So you will be ended up with minus 11,486. I'm changing it to kilojoules, so that will be minus 11.5 kilojoules. Okay. And the next one, work done in irreversible isothermal expansion, 1 mole of an ideal gas from 1 meter cube to 3 meter cube at 300 Kelvin against the constant pressure 3 kilopascal. Okay, the next one, work done of irreversible expansion. So minus P external of V2 minus V1, right? So that is 3000 because 3 kilopascal is given. V2 3 minus 1, so which will be 2 into 3000, that is 6000 joules, converted that to 6 kilojoule. And third one, change in internal energy of adiabatic expansion of 1 mole of ideal gas with delta T and CV value is given. Okay, so delta U is equal to NCV delta T, right? Now delta U, which is equal to 1 mole, and delta T value is 320 and CV is 3R by 2. 1 mole, 3R by 2, and this is 320. So which will give you, substitute the R value, let's say that is 8. Okay, so 1 into 3 8 is 24 divided by 2 into 320. This is, maybe this is 12 into 32. So 12 into 32, which will be giving you around 3900 joules. Converting that to kilojoule, you will be ended up with 4. Okay, so any 4, yes, this belongs to this and this will belongs to this. I'll give you the formula for this one also, that is delta H is equal to NCP delta T, correct? So all you have to know is all those formulas of thermodynamics. We already released a formula sheet, right? Today is the last day to download it for free, so please make note of it. Let's move on to the next question. Let me know how many of you make it right in your examination. The next question, the pH and conductance of weak acid was found to be 5 and 4 into 10 to the power minus 5, Simon. And the conductance was measured under the standard condition using a cell, whereas an electroplate's surface area is 1 centimeter square, where at a distance of 15 centimeter apart, the value of the limiting molar conductivity is. Okay. So first of all, they have given that this pH is 5. So if the pH is 5, what is the concentration of H plus ions? That is 10 to the power minus 5, correct? What they have mentioned is degree of dissociation of that weak acid is less than 1. It's lot less than 1. That's why 10 to the power minus 5. So let's calculate the cell constant, that is G star, distance by area. Distance is 15 centimeter and the area is 1 centimeter square. So which will give you 15 centimeter inverse. Right? Next, conductivity. Kappa, that is equal to G into G star. So this is 15 and conductivity is given as 4 into 10 to the power minus 5 into 15, which will give you 6 into 10 to the power minus 4. Right? Now what we have to do? Finally we have to find the limiting molar conductivity. So for that, lambda m is equal to lambda m naught by alpha. Substitute the values, kappa into 1000. Alpha value, we are taking it from H plus concentration. That's less than 1, right? So 10 to the power 5, minus 5. So I'm taking it from H plus concentration. So substitute the values, kappa we found out, that is six into 10 to the power minus 4 into 1000 divided by 10 to the power minus 5. So which will give you 60,000 Simon centimeter square per mole, right? But what they are asking it is Simon meter square per mole. So convert centimeter to meter. This question becomes 6 Consider the following electrochemical cell at 298 Kelvin. This is a cell given, and if the reaction quotient of at a given time is 10 to the power 6, then the cell EMF is. Okay, they have given the values also. First, let's find out the cathode, where the reduction happens, where the oxidation happens. So the cathodic part, always the reduction will happen. The reduction reaction would be bismuth oxide plus H2O plus 6 electrons, which will give you 2 bismuth, right? That is the change. Plus 6 OH minus. And the cathode value, that is 0.44. Similarly for anode, that is equal to HSnO2 minus plus 3 OH minus gives tin hydroxide, that is 2 minus plus 2 electrons. And the anode value is minus 0.90. Okay. Now we know the cathode and cathodic reaction. Let's calculate E naught. E naught cell, which is equal to E naught cathode minus anode. So 0.44 minus of 0.90 is minus 0.44 minus of minus 0.90, which comes out to be 0.46, right? So for that we are using the Nernst equation to find E cell value. So E cell is equal to E naught cell minus 0.059 divided by N log Q. So log Q value is already given as 10 to the power 6. So 0.46 minus 0.59 divided by 6 electrons, log Q, that is log of 10 to the power 6. 10 to the power 6 is 6. So which will cancel out each other, 6 and 6 cancel, remaining I will be having E cell is equal to 0.46 minus 0.59, that is nothing but 4 into 10 to the power minus 1. So in the question they have given dash into 10 to the power minus 1 volts. The answer is 4. Okay. Then the next one, the dissociation of gas A2 takes place. This is a reaction at equilibrium. Total pressure is 1 bar at 300 Kelvin. Gives energy formation A2A and given. The degree of dissociation of A2 is given by. Okay, where the X is. Fine. So what we have to do is, we know they have given the Gibbs energy of formation, right? So delta G naught of reaction, that is equal to A2 gives to A, right? So 2 delta G naught formation of A minus delta G naught of A2, right? This is A and that is A2. Substitute the values 2 into A, that is minus 50.8 minus this value is minus 100. So minus of minus 100. So which will give you delta G naught as, this becomes 100. This is also 100. 100 minus 100 plus 100. So need not to be 0 because I have more values. So remaining that value 8.832 into 2, that would be your answer, right? So that is minus 1.6, right? 0.832, 1.664. Okay, we found that is delta G naught of reaction. Now, which is in kilojoules, okay, degree of dissociation of A2. So we know that delta G naught is equal to minus RT ln Kp. Right, so this we found that is in kilojoules. Converting that to joules, 1664 minus 8.314 into 300 into ln Kp. Right, so ln Kp, that will comes out to be 0.667. Right, these values go on another side, 0.667. So Kp, which is equal to e to the power 0.667, which is approximately 2. Okay, remember the value, that is 2. Now we have the equation that is A2 giving 2A, right? They are asking about degree of dissociation. So we have to combine it with another equation. So initially, for this one, initially 1 mole and 0. After that, the equilibrium, which is forming 2 alpha, this is 1 minus 2 alpha, 1 minus alpha. So total number of moles will be 1 minus alpha plus 2 alpha, which is 1 plus alpha, right? That is total number of moles. Finding out the partial pressures of A2, that is 1 minus alpha by 1 plus alpha into P total, right? We know Kp, that is 2. How to find pressure constant, pressure equilibrium constant? That is Pa2 by Pa2, right? So substitute the values here. Pa, that is 2 alpha by 1 plus alpha whole square divided by, this one is 1 minus alpha by 1 plus alpha, right, into P total. What else information is given? That is total pressure is 1 bar at 300 Kelvin. Okay, so now substitute total pressure, that is 1 bar, that is okay, 1. Remaining, I am taking it on the another side. 2 equal to 4 alpha square by 1 plus alpha, 1 minus alpha, right? So which will become A plus B into A minus B. A square minus B square, right? So 2, 1 minus alpha square, that is equal to 4 alpha square. So you will be ended up with alpha square is equal to 1 by 3. So alpha is equal to square root of 1 by 3. They have given in the question, that is x into 10 to the power minus 2 square root, I mean into to the power 1 by 2, right? So I am converting that to x into 10 to the power minus 2. So which will be 100 divided by 3 into 10 to the power minus 2, right? So which is correct? Now 100 by 3 is 33.33. So nearest integer they are asking. So which should be 33. Okay, cool. Let me know how many of you are right in the exam. The next one, consider an electrochemical cell where the metal electrode M undergoes the redox reaction. The cation M plus is present in 2 different concentrations, C1 and C2 are shown. Which statement is correct, generating the positive cell potential? Okay. So positive cell potential have to happen means, then M reaction is M gives M plus and 1 electron. So for positive cell potential, M plus, that is for C2, gives M plus of C1, because cation M plus is in 2 different concentration. Positive means C2 have to become a C1, right? So what about E cell? E cell, we know that is minus 0.59. one electron only. So log C2 by C1. If this value is positive, E cell is greater than 0. If that is greater than 0, then C2 must be less than C1, right? So which of the following options obeys that? If C1 is at the cathode, or else if you are taking this one alone, C1 is present in the cathode, then C1 is not greater, C1 must be greater. So C1 must be greater than C2. Or cathode or anode. So here we know C2 is becoming C1. So option 3 must be your answer. All structural isomers with molecular formula C5H11Br when separately treated with KOH to give the substitution product without rearrangement, the number of product which can exhibit optical isomerism. Okay, so this will undergo the direct SN2 and Br position will get occupied by OH, right? So let's start from 1-bromopentane. 1-bromopentane, obviously it is not 3, 4, 5. It is not a chiral one, right? CH2OH will form. Then 2-bromopentane, which can form a chiral compound, that is 2-pentanol. Then other possibility would be 3-bromo. 3-bromo, which will not form a chiral one. It's an achiral one, right? What about 2-bromo 2-methyl? 1, 2, 3, 4, 5. So which will lead to the formation of, again this will be achiral after forming OH. And what about 1-bromo 2-methylbutane? Butane 1-bromo 2-methyl. So 2-methyl. So this position becomes OH. Obviously that is not also a chiral. This position will become chiral, not an OH. This part can become chiral. And the other possibility would be 1-bromo 3-methylbutane. Let's think about that one also. 1, 2, 3, 4. 1-bromo 3-methyl. 1, 2, 3-methyl. So that is not chiral. This obviously can't react also. This is tertiary. Okay, so what are the molecules having chiral? 1, 2, 3, which can exhibit optical isomerism. So 3 alcohols can show optical activity. If I am counting the enantiomers, both the enantiomers of this optically active compound, then that would be polar DNL, right? So that would be 6. But the entire answer is given as 3 only. Gram of non-volatile electrolyte solute of molar mass m gram per mole when dissolved in 100 ml of water decreases the vapor pressure of water from 640 mmHg to 600 mmHg. If aqueous solution of an electrolyte boils at 375 Kelvin and Kb for water is 0.52, then mole fraction of an electrolyte solute in the solution can be expressed as. Okay, so first of all, use the Raoult's law, delta P by P naught, that gives, using the Van der factor also, so which is I chi of solute, right? So which will be 40 by 640, that is this difference by 640, that's of pure. So which will be I into chi of solute. Next we have Kb, aqueous solution boils at 375 and Kb of the water is also given. and the pure water boiling point is also given as 373. So delta TB will become 2 Kelvin, right? So delta TB, that is equal to I kBm. So which will be 2 equal to I 0.52 into m, weight by molecular weight by how many grams? 100 ml of water, so which will be 0.1 liters. So weight by molecular weight divided by 0.1. I is equal to 0.52 divided by 0.1, that is 5.2. So this goes on another side. So 2 into mm by 5.2 into W. And from here, from the first equation, if you simplify, that will become 1 by 16. So let's substitute this value in the equation 1. Okay, so which will give you 1 by 16 equal to I value as 2m molecular mass by 5.2 into W into X of solute, right? So I want chi of solute, that is equal to 1 by 16 into 5.2 into W by 2 into molecular mass. So which will be 1.3 by 8 into W by mm. So what they have given, in the options they have given this value, which is option 1. Loss weight test is used for the reduction of nitrate ion, which involves the use of sulfuric acid and alpha naphthylamine reagent. In the above test, sulfuric acid is diazotized by the acidified nitrate ion, which on further coupling with alpha naphthylamine forms azodine. Okay, so first of all, the first statement, this INSPO test is used for the reduction of nitrate ion. That is true. And the reagents are sulfuric acid and alpha naphthylamine. Those are the reagents. So this statement is true. Statement 2, in the above test, sulfuric acid is diazotized by the acidified nitrate ion, which on further coupling with alpha naphthylamine forms azodine. Yes, nitrite we have, right? In diazotization also, nitrous acid we are using. So HNO2. So NO2 with this sulfuric acid, which is, I'm writing the reaction, that part, and HNO2 plus sulfuric acid, which can undergo this diazotization, as usual diazotization which can undergo to form azodine. Usually they give you aniline. Instead that we have the sulfuric acid. Okay, and the reagent test is somewhat advanced, but the simple question. So both the statements are true. A student performed analysis of aliphatic organic compound S, which on analysis gave carbon is 61, hydrogen is 15, nitrogen is 23. This compound on treatment with HNO2 and H2O produced another compound Y, which did not contain any nitrogen atom. However, Y upon controlled oxidation produced another compound which responds to the iodoform test. Okay, so first what we have to do is, this is the percentage, right? So from there we can, let's find out the molecular formula or empirical formula. So C hydrogen and nitrogen. Those are given. So let's do that in this method. 61.01 divided by 12, 15.25 divided by 1, 23.74 divided by 14. Right. So which will approximately give you 12, so 5 point something, and this will be 15.25, and 14 into 2, so it will be less than 2, 1.69. So the least number is 1.69, which will give you 3:9:1. So C3H9N. So that is a formula. Using that formula, we can treat it with nitrous acid and water, which should not have any nitrogen in it. That is our product. So if there is a primary amine that reacts with HNO2, it loses all those nitrogen and forms alcohol, because I have alcohol, right? So I have water. So after forming this diazonium salt, that will not obviously form because there is no benzene ring in it. After undergoing diazotation, it immediately forms a alcohol. That is my Y, alcohol. And which didn't contain nitrogen. However, Y upon controlled oxidation produces another compound Z. So Z responds positive to iodoform test, which means there is a methyl group present over there. So let's write it from backwards. So Z gives iodoform test. So I have only 3 carbon there. So CH3, CH2, CHO I can't write. So I have an option of COCH3. Let's try this one, which is formed from the oxidation of the alcohol. So the alcohol must be secondary alcohol. Right? And this is formed from the amine. So amine must be CH3, CHNH2, CH3. Given this series of reaction and asking us to find which in which reaction the products are right. The first one, as you see, I have NHCO within 2 benzene ring. 1:2 ratio, I'm adding acid. So which is forming NHCO NO2. That is not a correct reaction, right? That is a wrong product. Let me know if you know what product it will form. And here you see I have this phthalimide reaction. Aromatic halide does not give the Gabriel phthalimide, right? So this is not also a right answer. And what about the third one? I have CH2NH2 with carbylamine. Okay, and tin HCl. If tin HCl is formed, then the product would be NHCH, right? It will break like this, and NHCH3 would be formed, right? Not CH2NH2, obviously. One carbon is missing over here. So which is again the wrong answer. What about the D? CH2, C double bond O NH2 with half-man bromamide, which is giving us CH3, CH2. Yes, right. Right, half-man bromamide, which will give you 1 carbon less. So that is right. So only the fourth option is right. Ions having the same number of hyperconjugation are. Okay, so hyperconjugation, which is related with the alpha hydrogens, isn't it? So the first one, if you take, I have how many alpha hydrogens? 3, and then 1, 4, and then 2 on the other side, which is 6 alpha hydrogens. And the second one, I have 1, 2, 3, 4. H. So this is also 6. And what about this? CH3, CH2, and this is having 7. And what about this? 1, 2, 3, 4, 5. So the first two is having same number of alpha hydrogens. Let me know if you want the part 2 video of this kind of questions need to be solved, or else let me know if you want the whole PDF of all 250 questions from JEE Main January attempt. Okay.